Okay, so this is the third video dealing with trigonometric integrals, and we're still dealing with products of powers of sines and cosines. But I'm going to talk about case 3 here, where both the power of sine is even and the power of cosine is even. And so the trick there is you can actually replace sine squared x with this identity 1 minus cosine 2x over 2. And you can replace cosine squared x with 1 plus cosine 2x over 2. And so now that would reduce the integrand to lower powers of just cosine 2x. Okay? Okay, so on this one, I'm just giving you sine squared x times cosine squared x. Now, if these were raised to higher powers, you would still do the same thing as long as they're both even. But you would have to do more algebra in simplifying the expressions. Okay, so here I can replace sine squared x with 1 minus cosine 2x over 2. And I can replace cosine squared x with 1 plus cosine 2x over 2. Now, since I know if I multiply these together, I'm going to get 1 minus cosine squared of 2x, which is right here. And then it's going to be over 4. So I went ahead and factored the 1/4 out of the integral. Okay, so I'll have 1/4 times 1 minus cosine squared 2x. Now, I can actually break this integral up into two integrals, where one integral would be 1/4 times the integral of 1 times dx. So that would just be 1/4 times the integral dx. And then the other one would be 1/4 times minus cosine squared 2x dx. So that would just be minus 1/4 times the integral cosine squared 2x dx. Now this integral, we know how to integrate. It just integrates to x. So we get 1/4 x. But to integrate this one, I'm actually going to use that trig identity again. But this time, instead of using it for cosine squared x, I'm going to use it for cosine squared 2x. So if I double 2x, I get 4x. So now I can write cosine squared 2x as 1 plus cosine 4x all over 2. And then if I move this 2 in the denominator outside the integral, that would actually change that to minus 1/8. So I'm going to have 1/4 x minus 1/8 times 1 plus cosine 4x dx. And then bring the 1/4 x over, and then break this up into two integrals. So I have 1/8 times the integral of dx. Actually, I have minus 1/8. So minus 1/8 times the integral dx. So it'll give me minus 1/8 times the integral dx. And then I would have minus 1/8 times the integral of cosine 4x dx. So that would be this integral. And then I know this integrates to minus 1/8 x. So 1/4 x minus 1/8 x. And then when you integrate cosine of 4x, I'll leave you to do that, but if you integrate this, you'll get sine of 4x over 4. And then when you multiply that by minus 1/8, it'll give you sine of 4x over 32. And since I have a minus, I'll actually get minus sine of 4x over 32, or minus 1 over 32 times sine of 4x. And then, of course, don't forget to add your constant. And then the other thing you can do is, since these are like terms, you can say, okay, what's 1/4 x minus 1/8 x? And you can get a common denominator and show that that just equals 1/8 x. So your final answer is 1/8 x minus 1 over 32 times sine of 4x plus a constant. Okay? So that completes the three cases for sines of products of powers of sine and cosine. And on the next video, I'm going to show you oh, I'm sorry, I do have another example here. Hang on just a second. Okay, so I'm going to do another example of powers of sine and cosine, but the next example is going to be where both m and n are odd. So I'll show you that one in the next video.